All right, so let's do a few examples. So for example two, it says solve and graph. Okay, so two different steps here. And these types of questions are typically written in this like nice condensed format where they squeeze everything together into one question. Okay. So whenever you're dealing with compound inequalities, the first step is you have to decide, is this an and compound inequality or is it an or compound inequality? Okay, and it's real simple how you tell. If it says or, it's an or. If it doesn't say or, it's an and. Okay? If you see the word or, it's an or compound inequality. If you don't see the word or, no or, it's an and. Okay? It's pretty simple. Just look for this word and you'll be able to tell if it's a compound inequality. Whether it's an and or an or. So for example 2, example A, it says solve and graph. And it says negative 2 is less than or equal to 3x minus 8, which is less than or equal to 10. Okay, first ask yourself this question. Is it an and or is it an or? Do you see the word or? No, so this qualifies as an and compound inequality. Okay, both conditions will need to be met here. So here's how I'm going to do this. It's written in this nice, like, little condensed format where everything is back to back to back. It says negative 2 is less than or equal to 3x minus 8, which is also less than or equal to 10. Okay, so what I'm going to do is I'm going to split this up into its two unique questions. The first thing I'm going to do is I'm going to look just at the first half of this equation. I'm only paying attention to the negative 2 is less than or equal to 3x minus 8. Okay, I'm completely ignoring the less than or equal to 10. And all I'm going to do is I'm going to try to solve this for x. And I'll see what this looks like. So the first thing I'll do if I want to get x by itself is I'll add 8 to both sides. Negative 2 plus 8 equals 6. 6 is less than or equal to 3x. To get x by itself, I need to divide both sides by 3. 6 divided by 3 is equal to 2. And then I should have something like 2 is less than or equal to x. Okay? If I want to make this a little bit nicer, remember, the best way to write these is typically variable sign number. Ask yourself this question. What is the alligator eating? The alligator is eating the x, so when I rewrite it, the alligator should still be eating the x. X is greater than or equal to 2. All I've done is I switched the directions of these two. I put the variable first, and I kept the alligator eating the x. Okay, so I did the first half of it, and I got that inequality. Okay, now what I'm going to do is I'm going to solve the second half of the compound inequality. This time, I'm only going to look at the right half. I'm only going to look at 3x minus 8 is less than or equal to 10. So I treat this question like it's by itself. 3x minus 8 is less than or equal to 10. And then solve for x. I add 8 to both sides. 3x is less than or equal to 18. Divide both sides by 3. And I should get something like x is less than or equal to 6. Okay, and that's my second compound inequality, or my second inequality. Okay, so these are my two inequalities. And like I said earlier, this is an and compound inequality. So I need both of these conditions to be met. This is an and. Okay, so let's try to graph it. On the left-hand side here, I'm going to have my smaller number, which is always going to be, in this case, would be 2. And on the right-hand side, I'm going to have my bigger number, which is going to be 6. Okay. So the first thing I see here is I see x is greater than or equal to 2. It's going to be a closed circle at 2, and it looks like my arrow is pointing to the right, so this should be shaded to the right. Do the exact same thing for x is less than or equal to 6. Because it's less than or equal to, it's going to be a closed circle at 6, and my arrow is pointing to the left. And it looks like the sweet spot where the shadings collide is in this space in between 2 and 6. Okay, that is the graph of this compound inequality. Any numbers between 2 and 6 satisfy this statement. Okay, let's look at example B here. Negative 15 is less than or equal to negative 5x, which is less than 20. Okay? Ask yourself this question first. Is it and or is it or? Well, do you see the word or written out? No, we do not. Once again, this is once again an and compound inequality. Both conditions are going to need to be met. So let's split this thing in half. I'm going to look first at just negative 15 is less than or equal to negative 5x, and I solve for x. So to get x by itself, what I need to do is I need to get rid of that negative 5, so I'm going to divide both sides by negative 5. Okay, so when I do that, the negative 5's cancel, I'm just left with x. And on the left side, negative 15 divided by negative 5 becomes plain old just 3. Negative divided by negative is positive. But remember, whenever I divide or multiply by a negative, what do I need to do? I need to flip the sign. Flip, because I divided by negative 5. So instead of opening up to the right, I'm going to now change it to opening up to the left. Okay, and when I write this in the right order with x written first, okay, I'll have x, the alligator is eating the 3, keep the alligator eating the 3, should be less than or equal to positive 3. Okay, so that's the first one. Now I'm going to look at the second half of this equation. I'm only looking at negative 5x is less than 20. So do the second question. Negative 5x is less than 20. To get x by itself, I have to divide both sides by negative 5. These cancel, I'm just left with x. On the right side, 20 divided by negative 5 should be negative 4. But once again, we've divided by a negative, so we need to flip the sign. It was previously open to the right, now it's going to open to the left. X should be greater than negative 4. Okay? These are my two inequalities, and it's an and compound inequality, so both conditions need to be met. So let's graph it. So a smaller number always goes on the left. In this case, it's going to be negative 4. Bigger number is always on the right. In this case, it's going to be 3. Okay, let's start with the smaller number. X needs to be greater than 4, negative 4. So if it's just greater than, not greater than or equal to, it's going to be an open circle, and the arrows pointing to the right, I'm going to shade to the right. For the other one, x is less than or equal to 3, okay? It's going to be a closed circle, because it's less than or equal to. And the arrow is pointing to the left. The arrow is pointing to the left, so I'm going to shade to the left. And the sweet spot where the shades collide are in between these two numbers, between negative 4 and 3. Okay, let's keep going. So, for example C, we see our first example of an OR compound inequality. And how do I know immediately that it's an OR compound inequality? Because it says OR right there. Okay, so these are the ones where either one or the other condition needs to be met. So let's just break this up into its two separate questions. And it's nice with these because it pretty much does it for you. Let's just solve both these. I'll have 3x plus 1 is less than 4, and let's try to solve it. I'll subtract 1 from both sides. 3x is less than 3. Divide both sides by 3, and I should get x is less than 1 as my first inequality. I'll circle it. Then the other one is going to be this 2x minus 5 is greater than 7. Let's solve for x, add 5 to both sides. 2x is greater than 12. Divide both sides by 2, and I should get x is greater than 6 as my second. So remember, this is an OR compound inequality. It's either I have the blue condition met or I have the gray condition met. Okay, it can be one or the other. But graphing it's pretty much exactly the same. Start with your smaller number on the left. Let's change the colors here. Let's go to purple. Smaller number on the left, which is 1. Bigger number on the right, which is 6. Let's do the 1 first. Open or close. It's going to be open because it is just less than. My arrow is pointing to the left. So I'm going to shade to the left. Open circle at 1 and I shade to the left. Okay, any numbers that are less than 1 can work to solve this compound inequality, or the other option is they can be bigger than 6. Okay, so is it going to be open or closed? It's going to be open, and then my arrow is pointing to the right, so I'm going to shade to the right. Any numbers that are less than 1 or bigger than 6 work. The only numbers that don't work are between 1 and 6.